to go ahead and introduce Sara Lopez. Sara's been working with Preservation Inc. since 2007, first as the technical program manager, and then as the executive director starting in 2018. Sara holds a BS from the University of Michigan and an MS from the University of Maryland. Her graduate training and research focused on nitrogen cycling in the root zones of the Chesapeake Bay tidal marshes. Sara also raises and markets small livestock and serves as the agricultural representative on the Sanctuary Advisory Council for the Monterey Bay National Marine Sanctuary. Thanks for that, Sara, and thanks for presenting here.
Great, thanks for the introduction, Pam. Can you hear me and see my presentation screen?
Yes, everything's perfect.
Okay, great. Okay, so I've been working with Preservation Inc. for quite some time now, and we were recently approved as a third-party administrator for Ag Order 4.0 by the Central Coast Water Board. So I'm going to provide some third-party perspectives on vegetative practices and their role in Ag Order 4.0 compliance. There we go. So as I said, our approval came through as a third-party administrator in July of this year, and what we were approved to do is run third-party programs that assist growers in complying with monitoring and reporting requirements in Ag Order 4.0. And our website, I don't know if you can see my cursor, but our website is right over here, and I try to keep it updated with sort of the most current information as to the programs that we're offering and developing that's fit for public consumption. And so as we move through this fall and certainly into the winter, we'll have a full rollout and description, including fee structures for all the programs that we're going to be offering in 2022. With respect to surface water, which is really one of the main places that vegetative practices apply, we're going to be continuing to run the surface water CMP, which we've been running since 2005, the Cooperative Monitoring Program, and we'll also be providing a follow-up program for ranches in highly impaired watersheds. And the main thing to note is that, as Paula described, Ag Order 4.0 includes many numeric limits or water quality objectives that carry some pretty strict enforcements and penalties for exceedance for surface water quality. And it also includes requirements for the third party anyway to monitor riparian habitat and aquatic invertebrates or insects and other bugs. So sort of from the perspective of getting into compliance with these numeric limits and objectives, certain vegetative management practices can be really good options for either avoiding discharges or treating discharges from your ranches. But just skipping down, there's also often non-vegetative options that can provide similar benefits. And so just from Preservation Inc.'s perspective, we typically don't take a position in support of one type of practice over another. We kind of look more at mainly trying to maintain a focus on water quality and letting the experts deal with the management practice recommendations, but also just looking for overall cost effectiveness, feasibility for growers, and how effective it is at improving water quality. So sometimes a vegetative management practice is a really good option. For example, a grass ditch can help reduce or avoid ditch bank erosion. The non-vegetative analog to that is lining a ditch with plastic, and some growers do that, and that also serves the purpose. Vegetative buffers can block spray drift and trap sheet flows. Careful spray practices, low fencing, and just work on your plumbing can also provide similar benefits sometimes. Cover crops can help us to reduce or avoid soil erosion and discharge during winter storms. I thought I was going to come up with a non-vegetative substitute for cover crops when I was making this slide, but I actually didn't off the top of my head. So if somebody knows of one, you can type it into the chat for everyone to see. So those are cases where vegetative practices are good options, but there's maybe some non-vegetative options that growers have at their disposal as well, especially if there's a food safety concern. There's a few cases though where honestly I think the vegetative practices are going to prove darn near essential. It's hard to imagine another way for us to get into compliance with these Ag Order 4.0 numeric limits without relying on vegetation to a certain extent. So number one is if we're trying to meet numeric limits for turbidity, that's an indicator of eroded soil in the stream, especially when rain occurs. I have real hard time seeing how we're going to get there without vegetation on the stream banks. So when stream banks and other loose soil has plant roots in it, it's covered, it's stabilized, and we can't line the entire watershed with plastic. So again, it's really hard to imagine getting there without some degree of vegetation. And generally speaking, bare soils and banks don't occur naturally. So when we have those conditions, considerable effort is being spent in the name of food safety by someone to create those conditions. And then it's hurting us in our efforts to comply with the Ag Order. So here's just some example creeks. Both of these are CMP water bodies that we monitor. And as you can see, these, and I will also say there are some non-ag issues and maintenance going on in both of these scenarios as well. So this is, neither one of these scenarios is a 100% ag issue on the impacts to the riparian areas, but just comparing this top stream, maybe you can see my cursor, this top stream to the lower stream, somebody's gone to some effort to get rid of the vegetation up here. And then maybe also to scoop out silt from the bottom of this stream and pile it up onto the banks. And so that doesn't happen without some effort. And then when rain falls on these banks, it washes that sediment right back into the stream and creates turbidity. Now, this one, on the other hand, the lower one, it's certainly not an ideal riparian situation, but there's a pretty robust root structure here holding the soil from the stream banks or ditch banks in place. And so at least from the banks themselves, that's not going to be nearly the source of erosion or turbidity in a storm as this upper stream scenario. The other place I see kind of from a third party perspective as to where vegetation is darn near essential is going to be when we get into our bioassessment and PHAB or physical habitat assessment and RIPRAM scores. And I will define both of those terms in a subsequent slide. Those are things that are required of the CMP by Ag Order 4.0. And that vegetation can help offset aquatic toxicity from pesticides. And that is, just full disclosure, I don't know that that is a perspective that the Water Board would necessarily endorse, but it is something that we see in our data from prior years, and I'll talk about that in a subsequent slide. In a nutshell, stream bank vegetation provides habitat for aquatic organisms that have terrestrial life phases. So look up at the top right corner of this slide. The picture on the left is the nymph phase of the mayfly life cycle. The larval and the nymph phases of the mayfly life cycle are aquatic. So they live in the stream and they're affected by water chemistry. The mayfly adult phase is terrestrial, and it depends on streamside vegetation to carry out its adult part of its life cycle and reproduce. So if we don't have plants, we don't have those bugs, and then we don't have fish and other higher organisms. And so just going back a slide, think about, so in this upper stream here, there is nowhere in this scenario for that adult phase of the mayfly life cycle to have that phase of its life cycle, whereas down here, there's probably some vegetation that it can make use of. Okay, next, I wanted to just define those biological monitoring terms that I threw out a moment ago. So bioassessment involves the collection and identification of benthic invertebrates, aquatic insects, and other kinds of quote unquote bugs. And this is a picture of a field crew doing that collection using kick nets. They sweep along the bottom, and then this is a kind of a bird's eye view of the transect setup. This was a bioassessment transect that we did in the Salinas River, and that we are required to do again in 2023. So we go 100 meters upstream of our road crossing, and we cross that. We go back and forth across the stream A through K times, and on each of those cross-stream transects, we're collecting the bugs and making observations as to what's on the stream bottom. And then we're also conducting a physical habitat assessment of the vegetation on the stream bank, how stable is the bank, and other characteristics that affect aquatic life. And that's called PHAB. The new thing that we're going to be required to do beginning next year is called RIPRAM, and that's a rapid riparian assessment method. It's required annually for the CMP now, and in most CMP water bodies, we actually do not have permission to do this kind of a long upstream transect. And so RIPRAM is a simpler assessment method, and it can be done standing at the road crossing. And so that's why that requirement has been added to our monitoring program.
3 minutes, Sarah. You got about 3 minutes.
Okay, sounds good. One thing, we used to do bioassessment more frequently, and so I have a quote here from a report we did in 2009. Larry Walker and Associates actually did this report for us, and the quote is that poor habitat quality and high frequency of water toxicity also appear to co-occur. This does not indicate that one causes the other. More likely, it indicates a common external causal factor, and one or both, and here's kind of the take home, one or both toxicity and or habitat quality may drive the composition of benthic invertebrate communities at the CMP sites. And so this is one of the indicators we looked at, taxa richness. So how many different kinds of invertebrates were there relative to presence absence of sediment toxicity, which is usually due to pesticides at our sites. And you can see there's this big difference here. Taxa richness is much higher at the sites without sediment toxicity. But we also see this relationship between taxa richness and habitat quality. So the poor habitat quality sites have really low taxa richness, and it's right on up in a nice line. The optimal habitat quality sites have much higher taxa richness. And we also have sites that do have the sediment toxicity, but they've got the riparian habitat, and we actually find sensitive aquatic organisms at those sites. So Hyalella, which is one of our test species, we find it in Warden Creek, which has trees and vegetation in the riparian area, even though we also find toxicity from pesticides at that site. So there's a relationship there. Pam, I think I have 2 more slides here. I also wanted to talk about a voluntary initiative that we're taking on as a third party. We are trying to provide options. So these are totally voluntary, but in places where growers are having a hard time complying at the ranch scale, we're trying to provide some collective treatment options for the growers. And there's both vegetated options and non-vegetative options. So vegetated options would be, for example, this is the Molera treatment wetland that the Central Coast Wetlands Group has on Tembladero Slough. Here's an example of a non-vegetative option down at the bottom. This is a biochar flume that's in development, and we're working with Cures on developing that. And right now we're seeing between 30% to 100% removal of neonicotinoid and pyrethroid pesticides with this flume that has about 5 biochar bags in sequence. And we're running it at about somewhere between 50 and 100 gallons a minute with kind of low to moderate turbidity tailwater. Okay, so I just wanted to end by bringing the food safety considerations back into the discussion here. And we know that food safety is a serious concern, and it involves human health. So it is the highest concern, especially with leafy greens, for example, romaine and other lettuces, spinach, etc. Other produce commodities are lower risk, but they still present risks. And I cited 3 papers up here at the top right. And so a lot of the information on this slide actually came from these publications. These were surveys that were done of growers following the 2006 E. coli outbreak in spinach. And they basically established that growers faced varying degrees of pressure to mitigate food safety risk by removing vegetation and wildlife habitat near fields. And also that growers respond to those pressures in ways that also vary. So in response to that pressure, not every grower is going to remove the same amount of vegetation. We've also learned that the leafy greens marketing agreement does not require, nor does it support, extensive removal of riparian vegetation in the name of food safety. So that pressure is not coming from the leafy greens marketing agreement. So that kind of begs the question, where is that pressure to remove the vegetation coming from? Is it coming from the retailers, the distributors, the auditors? Is it coming from the growers themselves? I think that question probably bears some further investigation. And then there's this issue of scale as well, kind of field versus landscape. And I think Danny Karp in his presentation provided a lot of really good information and studies on that. So with respect to wildlife intrusion into cropped areas, we know that grower concerns are with respect to the field level. This research, which is being conducted largely at the landscape level, but it's not indicating greater intrusion, wildlife intrusion with surrounding vegetation. There's also this question that I've heard floated around as to whether or not there are food safety adverse landscape scale effects when vegetation is removed. So does the lack of native vegetation encourage wildlife to seek out the cropped fields? I think some of Dr. Karp's research suggests that that might be the case. And I've also heard some speculation that the lack of tall trees and other kinds of natural windbreaks enhance the movement of wind-vectored pests and pathogens, which could have food safety implications. It could also just have pest control implications. So very complex and weighty issues. And that's all I have.
Okay, thank you so much, Sara. That was a terrific presentation. Really good to see what's coming down the path with the third party and get your view on the vegetated practices and how they will be important to water quality. So